So we talked about factoring numbers like 12 into 1 and 12, 2 and 6, 3 and 4. Well, now we're going to look at factoring monomials, meaning one-term expressions, like 15 x to the third. So 15x to the third, we want to sort of separate it. We want to deal with the coefficient and we want to deal with the variables sort of separately. The factors of 15 are 3 and 5. The factors of x to the third are x, x, and x. And it's multiplication across all of them. So we could factor this a couple of different ways. We could factor this as 3x times 5x squared. We could do 5x and 3x squared. We could do 15 and x cubed. Right? These are all different factors. We could do 3x cubed times 5. We could do 5x cubed times 3. So you get the idea, right? These are all different ways we could factor out this one expression. We could factor them into all of these pairs of factors. We could even factor it out to negatives, like negative 3x times negative 5x squared. Noticing that that multiplication still results in 15x cubed. So let's say we wanted to factor something out of this polynomial, 3x plus 6y minus 3z. You have to try to figure out what is the common factor of all of these, and you could do a prime factorization to figure it out. 3x breaks down to 3 times x, that's pretty easy. 6 breaks down to 2 times 3 times y, and 3z, negative 3z, breaks down to negative 1, 3, and z. The common factor being 3 in all 3 terms. So that's what we want to factor out in this case. So we could rewrite this as 3 on the outside, x plus 2y, because that's what we have left here, 2y, minus z. That's factoring the 3 out of that polynomial. In the case of 12x to the fifth minus 15x to the fourth plus 27x to the third, if we want to factor out the greatest common factor of all of these, well, you might notice that the coefficients each share a 3, so we definitely want to factor out a 3. But look at the variable portions, right? We have at least one x. In fact, we have 3 x's in each one of these. So we can factor out an x cubed, leaving us with 4x squared minus 5x plus 9. There's also something called factoring by grouping. It's essentially factoring, but factoring twice in a row. So let's say we have a 4-term polynomial like this. 5x cubed minus x squared plus 15x minus 3. We're going to do something called factoring by grouping. And the first step is just simply grouping. I'm going to group the first 2 terms and the second 2 terms together. And then I'm going to look at each one individually and think, what can I factor out of these first 2 terms? Well, I don't have a 5 in both terms, but I do have this x squared in both terms, so I'm going to go ahead and factor that out. So I end up with x squared times 5x minus 1, because 5x cubed divided by x squared is 5x. X squared divided by x squared is 1. Then I look at this second group and I think, well, what do they have in common? Well, they don't have an x squared in common, but they do both share a 3. So I'm going to go ahead and factor out that 3. And I'm left with 5x minus 1. Notice that the 5x minus 1 and the 5x minus 1 are the same. That's important for factoring by grouping. It's not always going to happen. You're not always going to be able to make it work out that way. But if you can continue factoring this thing. If you don't, you're done. There's no other factoring we can do. Now to continue factoring, if I consider this whole thing a term and this whole thing a term, what do those 2 terms have in common? Well, we just said it. they have this 5x minus 1 in common. So we can factor that out of each term. So we put the 5x minus 1 out front, just like we would with anything else we're factoring out. And then we see what we have left behind. If I take the 5x minus 1 out of here, I'm left with just the x squared. If I take the 5x minus 1 out of here, I'm left with just the plus 3. And there, you notice now I have two binomials. So I've taken this 4-term polynomial, and by factoring it by grouping, broken it down to essentially two binomials.